Hello, Algebra 2 students. We are working through section 8.3, graphing general rational functions. So, when we graph rational functions that don't really fit into the two categories from yesterday, we follow a couple of general rules. So, we want to consider our x-intercepts, and when we are looking for our intercepts in general. So, to find our x-intercepts, you're going to set your numerator equal to 0, which often involves factoring first. To find your y-intercept, this is the same process we have always done. To find your y-intercept, you set x equal to 0. You're just going to get some number, and you're only going to ever have one y-intercept. You might have multiple x-intercepts. To find your vertical asymptotes from yesterday, we set our denominator equal to 0. Now, for these rational functions, we won't have any k transformations like we did yesterday, so we don't have to worry about anything out on the end that's getting added or subtracted to our fraction. Now, for our horizontal asymptote, we kind of break it into three main cases. Case 1, the degree on top is less than the degree on bottom. When that's the case, your horizontal asymptote will always be y equals 0. Just a rule. If your degree of the numerator is going to be the same as the degree of the denominator, just like yesterday, we are going to find our ratio of our leading coefficients. And good news, when the degree of the numerator is greater than the degree of the denominator, you have no horizontal asymptote to worry about. Now, when we plot points, we want to plot at least 2 points to the left and right of each vertical asymptote. Yes, I say each. Sometimes we'll have multiple. And when in doubt, go to your graphing calculator. Use your resources and check each problem, especially for your homework, on your graphing calculator, making sure that you use lots of parentheses. So we want to graph and indicate any intercepts and or asymptotes. So in example 1a, we have y equals x squared minus 2x over x squared minus 6x plus 9. First thing we notice is the degree on top is the same as the degree on bottom. Remember, it's the biggest exponent you see. So when that's the case, our horizontal asymptote is going to be y equals, well, the ratio of your leading coefficient. I have 1x squared divided by 1x squared, so it's 1 divided by 1. It's the ratio of my leading coefficients. I have my horizontal asymptote. Now let's consider our vertical asymptotes. We said to find our vertical asymptote, set your denominator equal to 0. Well, hopefully we're noticing that we can factor that denominator. It's going to become x minus 3, x minus 3. So because of that, our vertical asymptote, if we set either set of parentheses equal to 0, then we're just going to get x minus 3 equals 0, add 3 to both sides. Our vertical asymptote is going to appear at x equals positive 3. We'll go ahead and plot those on our graph already. So here's our vertical asymptote and our horizontal up at positive 1. Okay, now what about our x-intercept? Remember, to find your x-intercept, we're going to set our numerator equal to 0, and like I said before, that's going to involve some factoring. So to find our x-intercept, we want to first say, well, I can take out a GCF. Let's call this x times x minus 2. Setting that equal to 0, well, yes, we'll get positive 2 from that guy. And then since our GCF included a variable, we also have x equals 0. We just got 2 points without even doing a whole lot of work. So x equals 0 and x equals 2. Okay, not super helpful. They were both on the same side of one vertical asymptote, but that's okay. And then what about our y-intercept? To find our y-intercept, we plug in 0 for x. You can do it either from your factored form or from your original form. Either way, you notice that you get 0. Well, that makes sense because we already plotted a point at our origin. That's our x-intercept. It's also going to be our y-intercept. So now we just need to start plugging in points and seeing what happens. So pick at least